This is just the written part, by the way. Well, what are you talking about the written? So they said, we awarded points for good calculus work and conceptual points. Students must show their work. Okay? You guys know what a bald answer is?
No work on.
Exactly. No work at all. Okay? Students must communicate effectively, explain their reasoning, and present results in clear, concise, proper mathematical notation. I felt like grading them. A lot of times we did not use precise mathematical notation. They need practice in justifying conclusion using calculus arguments. Calculus arguments, not just arguments. A lot of presentation errors that they took off for is such things as parentheses, mathematical equations, and linkage. Linkage could be something like saying this is equal to this, which is equal to this. So on these 6 questions, here are the average scores for the AB ones. So out of 9 points on that very first problem, the average score was 2.57. Okay, on the second one was 2.56, and these are written down in your packet. Okay, 3.66 in this one. So you can sort of see these first 2 that you did that in the beginning were a little bit tougher. Actually, if you look at the first day, this one, and this one, tough problems, aren't they? If you look overall, they were tough for people that took them. Well, on the second day, you took this problem. Actually, no. I think what did you take? I think you took. Okay, so 5, 6. Okay, so yeah.
No.
So what did you take? 1, 2, 3, right?
Yeah, then 4, 5,
Okay.
6.
So I guess 3 wasn't so bad. Then 4 was a difficult one, and then you had 5 and 6. Now, what I'm going to do is I'm going to show you real quick the breakdown of our scores on these. Okay. Now, I'm not going to say I grade exactly like them, but on question 1, our average score was 3.31. Was that higher or lower than the average? It should be higher. We should expect more of this. Question 2, 4.38. Question 3 was 4.62. Next question, what are we on? 4? Fine. Okay, so 4.31, 6.0, so we did pretty good on that one. And then 5.23. Now realize these are going to be a little bit higher because I left off 2 of the tests, so it counted as zeros. For you have to retake the first half or second half?
I retook the
Second half, and yours was the second half. Yeah, so those second 3 problems, actually our averages were much higher, and we did well on that. What?
Thanks.
All right. Well, I meant as a class in general, but yes, yours were too. Now, as a teacher, I equate it to 2 things. One is, you guys are really smart, and sometimes I wonder, like, I used a different test for the written, and then I used a different year test for the multiple choice, because I know you guys being as smart as you are, you're probably like, oh, well, I know these questions are from this year's test. Let's look up other questions for day 2. You guys didn't even think of that? Oh,
I want
good.
to see what I actually get.
Good.
This is the final? Should have done that.
Well, at first I'm like, and maybe it's bad. I'm like, oh, these guys are really good in this. I'm like, did they think this through? That's why I made sure to use different multiple choice questions from different tests.
How long has the AP Calc test been going on? We're going to go through it every year, AP Calc test from like 1960.
Yeah, but yeah, I know. No, I'm just saying though, you could probably recognize some of those questions that, oh, that's this year's
Oh,
for some people that do them. And if you went through and did a lot of practice problems from all the previous AP tests, you probably saw these questions. So that's good. All right, so I want to talk about these questions, and basically, here's the first question, and here's a nice thing. Here's what they said when grading everybody's tests. Here's their general comments about the first question. And then I'm going to talk about the first question. Students did not perform as well as they expected compared to the first problem last year. They found parts B and C were easier than A and D, and they had a lot of trouble with the context. And I would say that describes you guys exactly. Okay, part A, common errors. Incorrect units or no units. Incorrect interpretation. Okay, G prime of 5. Failure to indicate the expression representing change at time t. An expression referred to an interval of time. And this is where I felt like maybe I probably could have taken more points off on some of these, so that's why I don't want to say this. They may take more points off, I don't know. But before we even get started with this, it might be good to sort of draw what's going on here. and get an idea of what's going on, because I don't think a lot of you really knew what the context of the whole problem was. So I want to put this in the context. What is going on here as we read this problem? So, on a certain workday, a rate in tons per hour. Right away we see rate per hour, or tons per hour, and we got to be thinking, it says rate. Okay, so this is a rate. All right? The tons per hour in which unproduced gravel arrives, so this gravel is arriving to the processing plant, is represented by this function. So this talks about what's arriving. It then goes on to say this is between 0 and 8 hours. So you figure, hey, during an 8-hour workday, this much is arriving. Okay, T starts at 0. The plant already has 500 tons of unprocessed gravel. And during those hours, the plant processes gravel at a constant rate of 100 tons per hour. So if I look at my unprocessed, okay, gravel, how much do I start with? I start with 500 tons. Am I adding or subtracting to that? What am I adding?
The G.
I'm adding this much per hour, right? And once again, it's good to know. Every hour, this is how much I'm getting. And what am I subtracting now?
100.
100. And then the 100 of it, okay, is being processed every hour. So I start with 500, but every hour, you can put T there. Actually, I don't want T there. I want this to be there. So this is just what's happening each hour. I start with this much every hour, okay? I am gaining this, but I'm losing this. So if you see the big picture, does that now make these questions a little bit easier to understand? I would hope so. So when the first question says, find g of prime, the derivative of 5, g prime of 5. Okay, use correct units. A lot of us didn't use correct units and interpret what's going on. Is this a rate that I'm starting with?
No.
Yeah, it is.
Oh.
It says right here. Okay, it's increasing in this many tons per hour. So right now my units is tons per hour. So if I find the derivative of this, what is it going to be?
Squared.
Tons per hour squared. And a lot of us didn't do that. So we were able to find the derivative. So what is the derivative of 90 plus 45? What did you get? Do we need to go through how to do that? You guys always want to go through everything, so probably. Is it t squared over 18? Okay. So here's g of t. So now what I need to find is, and by the way, you'll get a point for doing this part. I should show you the breakdown of points. Oh, it's okay. So you get 2 points for the part A. You get 1 point for, first of all, doing this, and then another point for finding g of prime of 5. So when I do this, I find its derivative. The derivative of 90 is what? 0. The derivative of 45, so mainly now I find the derivative of this. So it's going to be 45 what? Negative sign or positive sign?
Negative.
Yeah, I'll put this, I can put it here for now. Did I do anything with this?
No.
What did I do with the t squared over 18?
Find the derivative.
Find its derivative. What's the derivative of t squared over 18?
2t over 8.
Right? So I can really do that if it helps. So what I end up getting,
Or you took off the 1 over 18 as a constant?
yeah, I mean, that's, when I'm finding the derivative of t squared over 18, that's the same as 1 over 18 t squared. And then, you know, so I can do the derivative that way. So you then find the derivative, and I want to say, you can use your calculator as well, can't you? Was this calculator, right?
Yeah.
So some of you may have just done it all on your calculator as well. So this would be 1/9 sine of 5 squared over 18. Okay, put that in, and you need to make sure. I had to take off a point because we did not round to 3 decimals. You got negative 24.3 588. Do not go further, do not go less. Please do 25. Now, we talked about, is it increasing or decreasing? We talked about double negatives. And they will take points off if you do this. So you say then the rate of gravel is decreasing by 24.588 tons per hour at t equals 5 hours. That would be your interpretation. Do not, and we talked about it, either say it's decreasing at a positive or say that it's increasing at negative 24. Does that make sense? Do not put decreasing and negative 24. They will take a point off. I may have let it slide. I probably shouldn't have. But if you put a double negative, they said that was actually a common mistake that they had to take points off of.
So you can just say changing that.
You could say it's increasing by negative 24.588 tons, but I think it would be better to say it's decreasing by 24.58. All right, next problem. You basically want to find the integration from 0 to 8, and I imagine you guys did this on your calculator, right?
Mm-hmm.
Just make sure you get your units correct. Now, for problem C, it says, is the amount of unprocessed gravel at a plant increasing or decreasing at time equals t? A lot of us saw increasing or decreasing when we use this derivative, didn't we? But doesn't this tell you how much gravel we're going to get? And then we're taking away 100. So if I could find g of, what is it, 5? So I actually find g of 5 here. And g of 5 ends up being 98.141. So on the 5th hour, at time equal, by the way, so that means this is how much gravel is arriving, but how much gravel is leaving? 100. So is it increasing or decreasing? So you want to say the amount of gravel is decreasing at time equals 5, and once again, you want to say because, all right, you are only 98.141 tons of gravel are arriving, but 100 tons of gravel are leaving. So therefore, it is decreasing.
So you wouldn't find the derivative?
No.
Why
No.
not?
Why?
Yeah.
Because this function tells you, g of x tells you how much gravel is arriving at that time. So if you know how much is arriving, and you know, so you just want to know how much is arriving on the 5th hour. And you know at the 5th hour, 100 tons are leaving. So that's how you figure out whether it's in. So it's really just the context of the problem again. I know once you see that, once you see the question where it says rate, okay, or see whether it's increasing or decreasing, you want to automatically look at its derivative, don't you? But it's not. Because you have to relate it, how much gravel is arriving compared to how much gravel is leaving. So that's how you know. Okay? If 98 is arriving and 100 is leaving, well, the amount of gravel you have is decreasing. So that's probably the biggest mistake a lot of us used its derivative. Then finally, what is the maximum amount of unprocessed gravel? Okay. So if I take a look at this, I sort of want to use this function here to figure out when is the maximum. What does it say, maximum or minimum? Maximum. So I start with 500. It will increase. So I want to take how much, when do I get the maximum amount? Well, it's going to increase from 0 to 8 by this function. And you can use your calculator. By the way, you get a point just for writing this. And I subtract 100. So every hour I'm adding this much and I'm subtracting 100. And don't lose points for not doing this. Okay? You can put X here if you want. That's fine. So that's how you figure out when you're going to reach your maximum. Now, when you do this, okay, and you write out this integration, you get the following. You want to figure out when this, okay, I should probably put this as the amount of gravel you have. You want to find out when its derivative is equal to 0, because that would be a maximum minimum. Okay, so what's the derivative of 500? 0. And then I want to find the derivative of this. What would the derivative of that be?
G of X.
Okay. What do I do with the 100?
Would it be,
Well, if I'm integrating and taking the derivative, what does it end up happening?
so would it be just 100?
We want this to 100?
Because I'm taking the derivative of this integration. The derivative of integration is just whatever this is. It's our second fundamental theorem of calculus. So basically, I want to figure out when g of x minus 100 equals 0. And that's when I'll reach that. Okay. What is it? Minimum? The maximum amount. So when you solve this, and you can, by the way, you can use your calculator, use whatever, but when you solve this, you move this over and say, when does g of x equal 100? Well, g of x equals 100 at time equals 4.923480. The reason why you want to round it to that many decimals or leave that answer is because, remember what it asks. It says, what is the maximum amount of unprocessed gravel? Now, to make sure, and you need to show your work, do I know that's a maximum or could it be a minimum? Take a risk, you lose a point. So wouldn't I maybe want to put in and see what happens at a different time, like at 0 or 8? If you put 0 into the function, you use your calculators, you get 500. If you put 8 into the function, you get 525.55. And if you put 4.998, you get 635.37612. So you'll see that this is a maximum. It's not a minimum. Okay, and they asked you for the maximum. So when you enter your answer, you should put 635.376 tons of gravel as your maximum. All right. I don't want to spend this much time on all these problems, you guys. Let's go over number 2. We'll do number 2 a little bit more in depth as well. And then after that, we'll just. All right, a particle is moving along a straight line. Okay, this is the velocity of the particle. So you're given the velocity. So first question says, find all values of t in which from the interval from 2 to 4 in which the speed of the particle is 2. Now what does speed mean?
Absolute value of velocity.
Absolute value of velocity. So that means the velocity could either be equal to 2 or the velocity could be equal to negative 2. And a lot of us forgot to put when it's equal to negative 2, didn't we? So basically you set this equal to 2 and you set equal to negative 2 and you can solve it with your calculators. So I don't really want to go through how to solve it. But make sure you realize, okay, you have to do both. If its speed is 2, you have to do both positive and negative. And I would
So
say
speed is the absolute velocity, the absolute value of velocity.
yes. And we've talked about that before, haven't we?
Oh yeah, we did, but yeah, just keep confused.
Speed, we said, is always positive. All right, next question. Says, write the expression involving the integral that gives a positive s of t. Use this expression to find the position of the particle at time equals t. So if I write an expression for a position, what would I do to its velocity to get it to position? You would do the integration. Okay. Now it says yes. Well, when you integrate it, you got to put plus c, right? And so make sure when you do the integration, you add the 10. Some of us didn't do that. By the way, if you write it out like this first, just by writing this out, you get a point. So if you don't write this out, they will take a point off. If you write this, I imagine you'll get your full credit. But if you just give the answer, you definitely will not get 2 points. You only get 1.
My question is, so you can do something like your calculator, right?
You can do this on your calculator, yes, and you get negative 9.207. But remember, you got to add your initial value to that, which is 10. All right, next one. It says, find the time in which the particle changes direction. Well, the particle is going to change direction when its velocity is 0, correct? So what you want to do is figure out when is the velocity 0, and you'll see that the velocity is 0 at a couple points. These are the 2 points. Most of us would put these points. But you must give the reason. You must justify. If you did not put, sorry. Great. Okay, if you did not put that v of t changes from negative to positive. If you just said changes signs, you don't get that. You lose a point. You must say v of t changes from negative to positive, and from positive to negative. Do not just say it changes from positive to negative.
Wait, can you
Say
say
what does. What was that?
Particle changes direction. Then would you have to find the when it equals 0? I'm just going. I thought you had to find the when it changes direction would be the acceleration.
No, when the velocity is 0. Okay? Because think about velocity. This is my velocity. Right here, I'm going fast, but I'm still going same direction, right? Same direction. I'm just slowing down, but I'm still going the same direction. Once I get here, now I've stopped. And now I'm changing. Now when this goes from here, it changes directions. Because once again, if it doesn't change signs, if it comes down here, I can't just say 1 equals 0. Because if it doesn't change direction, go from positive to negative, now I'm going a different direction. All right, last question. And if you remember, we did, I remember we spent a review day talking about this. Talking about when is the speed increasing? Well, if I draw a graph, this is my velocity. Is my speed increasing? Yes. Now what's happening to my speed? Decreasing. Now what's happening to my, so now right here it decreases, now my velocity goes down 0. What's happening right here? Is my speed, it's increasing. So as long as, okay, this is positive, and if I look at my derivative, my slope is also going to be increasing. It's positive, right? So the slope is positive, and its second derivative, because this is getting steeper and steeper as we go. So as long as both the velocity and the change in velocity are both increasing, or if they're both decreasing, you're speeding up. Okay? So if v and t are if these are both the same, if they're both positive, or if they're both negative, I'm speeding up. Does that make sense? And then we did this on one of our review lessons. We talked about these things. Okay, because here, I'm going in this direction, so v of t is positive. My slope is also increasing, so the derivative of this is positive as well, so I'm going faster. Here, my speed's increasing because I'm speeding up in the opposite direction. So technically, okay, v of t is negative, obviously here. Right? And then if I looked at, once again, the derivative of v of t, because this is getting more to a negative value, okay, it is also going to be negative. All right. Now I want to be a little bit. I want to talk about the other ones, but I don't want to go quite as in depth. I just want to talk about some common mistakes. So number 3. For number 3, first question says use a data table to approximate C of 33.5. A lot of us did very good. You take C of 4 minus C of 3 divided by 4 minus 3. Make sure though you put 1.6 ounces a minute. Some of us did not put the correct units.
Wait, why isn't that square?
What?
Why isn't that square? Because we're
It says the one, this up here is basically just the graph of number of ounces.
Yeah.
So when I find that change, then it's ounces per minute. If I find that slope,
Yeah.
yeah, so it's ounces per minute. What's your question?
Oh. So, it's not ounces
B.
per minute.
It tells you that, right? It says, is there a time between 2 and 4 when C of t equals 2 and justify your answer? Well, what's that? You must use the mean value theorem, because if you do C of 4, erase this stuff. Okay, so C of 4 minus C of 3 all over 4 minus 3 equals 2. And you should show that work. Well, the mean value theorem states, first of all, it says, is this what? Oh, 2. Sorry. So, our mean value theorem basically tells us that there must be a value between 2 and 4 that will have a slope of 2. So you want to show this work and show that this is 2, you get a point for that, and then you get a point for saying because of this, the mean value theorem, you get another point. If you do not say because of the mean value theorem, you will not get that point. Okay, so that's where you got 2 points for. All right, 6 says use the midpoint sum. So basically MRAM. So I'm using my midpoint. And it says approximate the value of 1/6. So I want to find 1/6, and then I'm going to find the integration of what? They say, oh, C of from 0 to 6 of C of t. So 1/6. Now, if I'm using middle rank, the length of each unit is 2, and then I'll take the value between 0 and 2 is 5.3. Length of the next one, so these are my rectangles. I take the middle value, so the length, I use the value of 3 because that's between 2 and 4. And then between 4 and 6 is 13.8. Now this was non-calculator, right?
Yeah.
But when you add these up, okay, you should be able to do this without a calculator, 10.6 and blah, blah, blah. You would have got 60.6. You should be able to take 1/6 this. 1/6 of 60 is 10. 1/6 of 0.6 is 1. But now we need to have correct units. 10.1 what? Ounces. Yeah. All right, last one. Once again, this is non-calculator. Some of you are like, well, man, that's not fair. How am I supposed to do this calculation without a calculator? So it gives you the following and says it wants you to find the derivative. Well, I don't know if it says that, but you find its derivative. So use the model, find the rate. Well, obviously, if this tells you to find the rate, you take its derivative. So if this is b of t, you want to find b prime. Do that and then find b prime of 5. And the reason why I say do these both, because you get a point for doing this and a point for finding this value. So if I find this derivative, okay, the derivative of -16 is simply 0. How do I find the derivative of this? Now this is non-calculator. So I take -16 e to the -0.04t times the derivative. What's the derivative of the?
It's 0.4, not 0.04.
That's why I don't like drawing these. So the derivative of negative 0.4t. What's the derivative of this then?
Negative 0.00.
So now you actually have to multiply these without a calculator. Can you do that?
No,
Can't.
no, I'm sorry.
So 16
Over
times
25.
0.4. I keep on writing this wrong. So that
times
would be-
divided by 5, 32 over 5.
6.4. Okay, and this is a negative and this is a negative, so b of t would be 64 e to the negative 0.04t.
Would be 6.4.
6.4.
Yes. They put the word there. So you get a point for doing that. Now when you put 5 in, so it'd be 6.4 e to the negative multiply. Never put zeros. What's 0.4 times 5?
2.
Negative 2. Oh yeah, the negative
Right,
outside
yeah.
here, but. So this would be your answer. Or some of you wrote it like this. That's probably even better. But that's it, you just leave it like that. You don't have a calculator, so they don't expect you to know what E of 2 is. At least not the 3 decimals. 2 decimals, sure.
But you have to write like units and
No.
stuff.
No. Sorry, what was that?
Because you say
Alright,
unity.
units. What are the units in this case?
The amount of coffee.
Ounces per minute. Oh, real quick. I forgot that last problem. Did I erase it already? Yeah, I did. That last problem, once you got 10.1 ounces, it asked you the question to explain what that meant. And you needed to say that, and this is where a lot of people lost points. Because that last problem, how it said 1/6, if it took 1/6 from 0 to 6, what would this be then?
The average value.
The average. And a lot of us did not put average. It just said the amount of coffee in a cup in ounces over the interval. It should have been the average amount of coffee because this 1/6 that gives you the average. All right, problem number 4. We did much better on this one. I think almost everybody got it right. Okay, because it's the basically when you go, it's the only critical value where it changes from a negative to positive, so it's a local minimum. Next one, part B. I'll try to draw this out as best I can. Sorry this class isn't as most exciting, but we've got to go through the little details. So what you have to realize with this graph is they tell you at this particular time, they tell you that the value is 4. Okay, and then they ask you, when is, determine the absolute minimum of the graph. So to find the absolute minimum, you're supposed to look at what to find an absolute minimum? Critical points, and what else?
Where something equals 0.
Well, we know that if we're looking for the minimum, we look at
Endpoints too.
local minimums. So we need to make sure you look at both endpoints and your local minimum. You don't necessarily need to check my local maximum. It's either going to be the endpoints or a local minimum will be my minimum value. So my endpoints, I need to check, in this case, f of 0. I need to check, this point here was my local min, so I need to check f of 6, and I need to check f of 8. If you didn't check all of these, the endpoints and that local min, you lost points. So you got 1 point for considering 0 and 6 as well. And of course, the 8. You got 1 point for your answer and then 1 point for justification. So when you do this, basically what you're going to do is this is going to be equal to 4 minus the integration from what, 0 to 8? Because what I want to do then is I'm going to subtract what I added. That's what I would have started with. So I added how much here did I add to get 4? Well, if I take 4 and I subtract it, that's what I started with. Alright, so that would be the first one. By the way, what is the graph? F of prime, right? Okay, if you're using x, please put the x there. Some of you guys lost points for not putting the dx. Alright, and then this would be equal to 4 minus from 6 to 8. So if I subtract this off, I can figure out what this value is. And then I'd want to just say at f of 8, we know the value is 4. So in any case, when you do this, you should have figured out, it tells you these areas, right? It tells you the area 6, so you should then be able to go back and figure out what that is. So this would have been 4 minus 12. 4 minus 12, which is negative 8. This would have been 4 minus 7, which equals negative 3. So this would be its minimum. So the absolute minimum value of that in the closed interval is negative 8. All right, next it says, when is the graph concave down and increasing? So it's increasing basically when its derivative is positive. So it's increasing from here to here, from here to here, and from here to here. The question is next, when is it concave down? If it's concave down, is the slope needs to be increasing or decreasing? Which one would it be? Every time the slope is getting smaller and smaller and smaller if it's concave down. Does that always say concave down?
Yeah.
So see how the slope, while it is positive, it's getting smaller and smaller right here? So we'd say from 0 to 1. And once again, you need to justify your answer. You'd say because it is, because f of prime is positive, but the slope of f of prime is getting smaller and smaller. This section right here would be the same. Okay, it's positive, but the slope's getting smaller and smaller. So those are your two sections. And then the last one. A lot of us forgot to use the chain rule on this. So it says the following. It tells you that f of 3 equals negative 5/2, and I want you to find the slope of the tangent to the graph at g when x is 3. So basically what I want to do is I want to find the derivative of this and then figure out what the value is at 3.
What
To
is this
find
one?
what?
Where does it say that you need to take the derivative?
Because it
What
said if
slope
you want to
of
find
the
the slope of
line?
the tangent line, you got to take its derivative. So the derivative of this, using my chain rule, would be 3 f of x squared. But a lot of us forgot to do this, didn't we? You got to take the derivative of the inside. And this was probably the biggest thing that was missed. So, let's see.
Is this times up on that? Not close.
Oh yeah, times. I'm only talking plus 10. All right, so then, what do you want to do? We want to find 3. So we know that 3 parentheses f of 3 squared plus f prime of 3. Now this we know, they told us this part. This is what, negative 5/2? Stop doing that. And what is the derivative at 3? So if you look at the graph,
4.
it would be 4. How'd you get that?
Look at the graph. On x equals 2.
Yeah. You go to 3, value is 4. So you just look at that. All right, so then you clean that up and you end up getting 75.
Yep.
No units.
You know, but I got -2.
I feel like this is like the longest day ever. All right, do you guys want to go over the last two, or you had
Yeah.
enough? All right, question 5.
We don't have time, we just.
We have time.
One.
Remember, we got 7 minutes.
Oh yeah.
6 minutes.
These will be easy to explain too.
5.
4.
3.
3. 2. 1.
Okay. So you got f of x and g of x. Which one's which? So let R be the region bounded by the graph of f and g as shown to the right, actually. And find the area of R. Now, first thing you want to do is figure out which one is which. Which one's fx, which one's g of x. And how do you know that? How'd you get that?
I know my graph properties. This is
You
like
do?
X.
Alright, well, what is f of x? F of x is a quadratic that opens up or down. Why is f of x open down?
Well, I mean, I just found the
Radius is X squared.
points that intersect, like, divided by 2, so then it was x squared minus 3x plus 2, and then the points it crosses the x-axis are 2 and 1, which is where it crosses there.
How would you figure it out?
Well, first of all, I would know that 2x squared minus 6x plus 4 is a quadratic with my a value is positive, so I know it's going to open up like that.
So I said.
So this is f of x.
Yep.
This would be g of x. That's how I would do it.
Okay, so then the top of G of X.
Well, it has to be, because this one, I know this one is a U-shaped, so it has to be this. I know this is opening upward because the a value is positive. So now when I do this, if I want to find the area of R, what I will then take is this is my upper bound. So I take the integration. This goes from 0 to what? From 0 to 2, I'll take the integration of, my upper bound is g of x, minus my lower bound, which is f of x. Please put d of x. Okay. So now, it wants you to actually find this, doesn't it? It says find the area. So to find the area, I now need to take the integration from 0 to 2. See, g of x is, I didn't write up there. Make sure you put parentheses here. Some of you guys forgot your parentheses. I'm telling you, they will take them off. Points off. All right. So when I do this, the integration of both parts. Okay, so I'll integrate these separately. So the integration of this would be u substitution, if you want. So u would be equal to pi over 4x. So du would equal pi over 4. So I want to do 4 over pi du equals dx. Okay, so I can do that. So I don't know if you need, so this would end up being 4 over pi 4 sine of pi over 4x. Once again, that's how I do it, use substitution. If you want me to go through all the steps, I can do it later. And then I take the derivative of all this. So this would be 2x to the third over 3 minus 6x squared over 2, which yes is 3x, plus 4x. Make sure you use proper notation at that point. Okay, that needs to look like that. So now what I do is I put 0 in, I put 2 in. Nice thing is, what's the sign of 0?
It is 0.
0.
Oh.
Sky for the win.
Okay. So really, when I subtract the 0, it just ends up being 0. So I really just have to put 2 into this.
I was in the next step. Sine of pi over 4.
So this would be 16. If I multiply these together, I get 16 pi, or 16 over pi. This will just be
Sine of pi over 2, which is 1.
sine of pi over 2, which is 1. And then I want to subtract. Okay, when I put 2 in for that, I'm just going to cheat and tell you it's 4/3. So it's 6, and just leave your answer as 16 over pi minus 4/3. And that's how you leave the answer. Next one, it says, now, these are where we have struggles. It says, now you want to rotate about the line y equals 4. So now I'm rotating about the line. So if you look, I'll have, like whatever this is, I'll sort of have this gap. This will be like my inner circle and my outer circle. So a lot of us got this mixed up. And here would be how you do this. So you want to take the integration, and we'll pull out our pi once again. And then we take, this should be our, this here is like our outside. Okay? So from here to here would be our outside. This would be the whole inside. So to find this length, like here, if this is close, I take 4 minus this value. And then it's what? F of x. Oops. I'm going to just finish this one if you want to stay and see it.
Can we keep these or no?
Tomorrow you probably can. If you want, I guess you could. So in any case, what I do is I take 4 minus this to get my outside. I take 4 minus this to get my inside. And this would be the outside, inside, squared, big R squared, little r squared. How I do that. I don't care. Now on the package you picked up, okay, every day I'm gonna give you a couple problems to work on. So there should be 2 problems for you to work on, because I think we need to get a little bit more practice at the short answer questions. Yes.
Could you like post this online so we could look at it later? Like the answers?
Sure, I can print it up if you want.
So we can
Oh, if you want your scores.